So you got 50. Now let's say this is the average discharge. So have you got 50? Okay, so close to 50. So let's say the peak discharge is 1.25 times this Q average, because we have calculated an average discharge for the whole month. Now at any given time, let's say this is the peak discharge. .5 meter cube per second. So now this is the discharge that we need to design the channel for, and we need to make sure that sediment is at rest. So the sediment should not be moving for this discharge. So when we say designing a channel, what do we mean? So designing is fixing the dimensions for the channel. So what is this width B? And what should be the flow depth? Y. And of course we can assume what is the side slope. So let's say I want to design a trapezoidal section with side slope of what, let's say side slope I want to take is half horizontal to 1 vertical. So this I'm assuming and I'm fixing this. I need to find what is the width and then what is the height for this channel based on the discharge. Slope. Okay, so if the slope is given, then we take what is the slope. If the slope is not given, then we can assume it. So either 30 degrees, 45 degrees, or whatever. So in this case, I think the slope is given as 30 degrees. So theta 1 is it is 130, like the 5 is 7. So basically, you would get a relation between what is the shear stress on the slope and on the. So what would this ratio be? 0.5. Now, say tau naught is the actual shear stress on the head, then the tau on the sides is 0.5 or 3. So is the critical condition. So critical condition is when the flow is just enough to start moving the sediments. So whereas tau naught is the actual condition. And gamma RS from open channel flow. So now RS is at the actual condition. If at the critical condition, So I'm going to R at the critical condition RSC. So RS itself would be the hydraulic radius multiplied by the slope at the actual, and at the critical conditions the hydraulic depth will be RC and the slope SC. So in this, can you identify what would be the critical condition? So what is critical condition? So what is critical? So when it is just equal to, so when the diameter is just equal to 11 RS, then the sediments will start to move. So that is the critical condition, right? So this, we don't know how much this is. So this actual could be less than tau c or it could be more than tau c. So now R I replace with actually wait. So this RS would replace this tau c. So this is the critical condition. This should be less than or equal to tau c by tau c tau c by tau c should be less than or equal to this. So this would be the actual stress on the slope. So the actual stress should be less than or equal to 0.5 times the. Hmm? Yes. And then from the critical stress, we have the relation for RS and diameter. So if I replace RS critical with D by 11, and if the diameter, I know what is the sediment in the field. Let's say that that's given as 5 centimeter in the question. So you would get what is R from this relation. So the only unknown here is the slope is also given in the question. So now D is also given. So the only unknown would be R. Different combinations of. Yes. 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 So it depends on the discharge, right? So for a given discharge, if you fix a depth, for example, then the width is going to be fixed for hydraulic radius. Now the value that you get. Yes. S is 1 in 1000. So what did you get for R? 3. So the hydraulic radius is less than or should be less than or equal. So hydraulic radius is A by P should be less than or equal to 3. Now, if we assume if it is a wide channel, then we could say approximately the depth should be less than or equal to 3. And so I'm going to start with the value of y, let's say 2 meters. So I'm assuming a value of 2 meters. And then what can we calculate from the depth? So we can calculate what is the area for this depth. Because do we have everything? So P is still unknown, the width is still unknown. So here we only know y, but we don't know what is the width. Velocity using? Yes, you can do that. So we are going to use Manning's-Lien as well. So, and we need to check for the discharge. So whether we get the same discharge or not. So your area would be a function of P because the P is the only unknown. And then your perimeter is also going to be a function of P. Your R is also going to be a function of P. So what is this for a trapezoidal section? Yes. So we are assuming like this step, assuming it is a wide channel. So for a wide channel, R would be y. So y would be less than or equal to 3. So we start with a value of y equals to 2. So what is the expression for area? So basically here you would get area in terms of B, perimeter B, and R in terms of B. Say we assume some B value, let's say 6 meters or 7 meters. So you assume B value and you, you substitute B into these terms. So you get A, R. So if R and S, what equation can you use to get the velocity? So you can use Manning's velocity. So now we got velocity and we also have area. So what is discharge? So what are the discharge that you calculate should equal 62.5. So if that is not coming to 62.5, then you need to change B, let's say 7 meters or decrease it to 5 meters. So you have to do trial and error to make sure that you arrive at the same discharge. So initially we have fixed the depth meters. For this depth, we are now designing what is the width of the channel. So area would be a function of the width. Perimeter is also a function of width, and so is the hydraulic radius. And now I'm assuming the width B as 6 meters, and I'm calculating what is the area, perimeter, hydraulic radius. From there, get what is the velocity and calculate what is the discharge. So this should equal the same discharge as 62.5. So if not, you need to change B. 4 root 3 plus B. B plus 2. Plus 2. It's a question section. So bottom width plus, so bottom width plus the side slopes. Yes. 5 by 2. Theta is 30 degrees. B plus 8. So this is the hydraulic radius. Use 6 meters, what do you get for area? Twelve point nine two. And perimeter? 14. And hydraulic radius? Now what is the velocity? N. So let's say N is 0.02. So what do you get for velocity and discharge? What is the velocity? And then the discharge? 19.03. So the discharge is much smaller than 62.5. So we need to increase the discharge. So maybe in the next try, I would try B is 10 meters because the discharge is almost 1/3. So I would increase the width to 10 meters and try again. So we need to do trial and error until we get the same discharge. So now we have fixed the dimensions B and Y. So this channel would ensure that there is no sediment getting eroded from the channel. And in the next class, we will see how we can design so that whatever the sediment is coming in, it has to remain in suspension. So it should not settle down or there should not be no erosion. So that is called Kennedy's theory. It's based on a lot of empirical data. And after that, we'll see Lacey's theory, which is also based on empirical data. So I hope you will finish this unit in next 3 classes, next week. And the quiz will be the week after. So the quiz on unit 2 will be the week after, not next week. Right, so we have 10 minutes, so we'll do an activity. So I want all of you to form into 5 groups of equal number. So all of you please come forward and form five groups of equal number, and we are going to do an activity now. Yes, please come forward. All of you, please come forward. Settle down as 5 different teams.
Just someone has marked my attendance on 23 and the answer
No, no, thanks.
this question will be given in the note.
Yes. Yeah. Okay, so we have 5 teams, and each team I'm going to assign a role. So one team starting from there would be public, and the second team is volunteers. Third team is first responders, and third you have the bureaucrats, and then you have the engineers. Right. So in one of the lectures, I asked you to think about flood scenarios, right? So I asked you to think about one flood event that you may have experienced or seen on news. So now we are going to imagine there is a flood event, and you are the public. So I want you to think, what is your role as a public during a flood? What is the information that you require as a common man? And what is the information that you can provide to others? So that is your role. So you need to discuss as a team. What is your role as a common man? What information do you require during floods? And what information can you provide to others, right? So volunteers, so you need to decide what is your role during flood. So how do volunteers help? So during the flood or after the flood, I want you to think as the volunteers who could be there to assist others, or you should come up with your role and what information do you require during the event as volunteers, right? And first responders, you could be like the NDRF or CPRF who are getting into the action. So if you want to get into the action during an event, what are your responsibilities? What information do you require to get into action? And what information can you provide to others, like public or volunteers or others in that list?
I've seen a whole web series on 911.
Okay. Yeah, yeah, sure. So you should discuss with your team and come up with some points. And you have the bureaucrats who make the policies and laws. So you need to think about what policies or laws and in the context of floods, right? And what information can you provide to others? And you are the engineers. So what is the role of engineer? Either to prevent the floods or during the floods. And what information can engineers provide to others during the flood? So I want each of your team to individually discuss first. And when you are discussing, whatever the outcomes that you come out with during the discussion, write it on a paper. So with your team name, list out the points that you have discussed. Yeah.